Okay, so welcome everyone to this session. This is the techniques and tools to improve the Salesforce development cycle. So thanks for coming. My name is Stefan Gore, and I'm here from Dublin in Ireland, and I'm here with the TAS group. So I've been with the TAS group for about 4.5 years, and I'm a software engineer, and I have a particular interest in managing code and release procedures. So this is kind of why I'm interested in the content I'm going to present today. And I'm just going to be talking about the tools and techniques that we at the TAS group used to try and improve our Salesforce development process. So who is this talk aimed at, or who will benefit from this? Well, I suppose anyone who's doing large-scale development or enterprise-level development in Salesforce could benefit from the tools we're going to discuss. So I guess in particular ISV development teams. But also teams who are new to Salesforce, teams who've previously worked in the traditional approaches of having source code that's compiled. That's the kind of background we came from, and teams who are used to techniques of having things like version control and continuous integration and so on. I'm sure people who've worked in things like Java and .NET and so on are familiar with those. And this talk is kind of around how we bring those techniques towards Salesforce development. So some of the things we'll discuss in the session. So how do we reduce the obstacles for our development team? How do we manage our source code? How do we automate our testing? Improving our feature development, and just generally how we made the whole development process better for us. So just a brief introduction to the TAS group. So the TAS group help sales companies to be more effective and efficient by using software to implement the TAS methodology. And basically what that means is we try to help companies increase their win rates and their deal size and decrease their sales cycle length. So originally the TAS group had their software implemented off the Salesforce platform. We had it implemented on a Java stack. And it used to integrate with a number of different CRMs. And when we had this system, we had the usual sorts of version control and continuous integration and so on that you typically find in any Java development team. However, about 2 years ago, the TAS group made a strategic decision that they were going to move to the Salesforce platform. It was a kind of an easy decision for us to make based on our business and just the facilities that Salesforce gave us. So we became a Salesforce ISV, and we now have many large managed packages. So our main core package has over 5 million characters of Apex, just to give you an idea of the size of our code base. So when we moved to the Salesforce platform, we encountered a number of problems. Or, well, maybe not so much problems as issues that we had to understand and things we had to overcome. For instance, we weren't familiar with how to work with developer orgs, patch orgs, publishing orgs, and so on in an efficient way. How are we now going to manage our code, because it's no longer stored locally, it resides in the cloud on these Salesforce orgs? How do we manage features among the team now that we have individual orgs for doing development? And how do we do our automated testing? So Salesforce provides lots of very, very useful development tools. I'm sure we're all familiar with the tools they provide, and they are very good. But we did find that there were some things were slightly lacking, like this, source code management, continuous integration, and those kind of things. And it is possible that Salesforce have a solution that's on the way. We just couldn't find any information about it, so we had to come up with our own ways of solving these problems. And that's what I'm going to be talking about in this session. I'm not sure if any of you saw some of the other sessions. There were some very useful sessions that were quite relevant to what I'm going to be talking about today. Did anyone see the code science session, continuous integration for Salesforce ISVs? Yes, I thought that was a session, and it was quite similar to some of the stuff I'm going to be talking about today. And similarly, there was another session in this building here. It was done by John Stevenson. Keep your code and metadata under control with Git version control. Did anyone attend that one? Yeah, so hopefully the stuff that you'll have seen there will be relevant here as well. And to anyone who did miss those sessions, I'd recommend you look back and see if you can look them up afterwards. They had some good information there. Okay, so what were the challenges we faced when we moved to the Salesforce platform? So the first thing was, well, we were all Java developers, so we were all familiar with Java, and now we had this new platform and new technologies to learn. So we had to learn things like Apex and Visual Force and SOQL and the formula language and so on. So while it seems daunting at the start, the Salesforce community is very, very strong. The documentation is excellent, and it really wasn't the issue that we thought it might be. So that didn't turn out to be as big a problem as we thought. The next thing we had to consider was the restrictions from working in organizations. So we were all used to working in our own local environment. So you have all your files locally, you have your local compiler. You know, every developer can just work away almost in isolation. But when you have organizations, your code resides in the org, so you're saving code up to an org. And this was a different concept for us. So we had to figure out how we were going to work with that. Next, we had to figure out how we were going to manage version control. So previously, developers would check code into version control, or whenever we had files that were working, you could commit them to whatever your version control tool was. Now these files weren't local, so how do we manage our code that's in the org? And also, how do we make sure that we don't lose our code? So our code isn't residing locally anymore, it's residing in this org. What happens if something happened to that org, or somebody accidentally corrupted all the code in that org? Have we lost our content? We need to make sure that that wasn't an issue. Next, we had to consider how we were going to do automated testing. So testing is just important. I think every engineer is aware that no matter how diligent an engineer is, manually testing just won't quite get you there. You need to automate your testing. And it's just to ensure that your code doesn't get broken by changes and that new code does what it's intended to. So then we'll look at isolated feature development. So this is just our way of trying to make sure that we don't bring in dependencies between features, or and we also minimize the amount of conflicts going on between developers. I'll go into that more later in the session, but that's one of the things we'll be talking about. And then finally, I'll be talking about continuous integration. So just making sure that we frequently reintegrate our code, because if you leave different branches or versions of your code away from the other working version or versions you're working on, you can end up with very complicated reintegration problems or merge problems. So you want to do this as often as possible to keep those merges as simple as possible. So we'll start by looking with how we dealt with the organization restrictions. Okay, so as I mentioned, this was a bit of a change for us because we no longer had our local files and our local compile. We were now saving files from our local machine up to this org, and it was being compiled in the org. So that was a different concept for us to get used to, but it wasn't too bad. But the problem that we were finding was when you have many developers working in one org, and they're working on the same file and then the same lines, you end up with lots of conflicts. One developer tries to save, then the next one tries to save, and they just end up having to continuously resolve conflicts in the files. So we had to come up with a way of avoiding those conflicts. Then the other thing is, in Salesforce, as I'm sure you're all aware, you have your publishing org or your packaging org, where you create your managed packages. And it's important that the code in that org always remains stable. If the code in that org becomes unstable or has failing tests, you can't release packages, and that's going to hinder your business. So you shouldn't do development in the packaging org. Development, just by the nature of it, when you're working on new features, will be unstable until the code is ready. So working in the packaging or publishing org is a bad idea. So that's why we work in development orgs. However, the issue with development orgs is they take a long time to set up. So I've shown here the process that's required for us to get a development org going. So we have our partner portal where we raise the case to get the org created, which can take a bit of time. Once the org is created, we have to make some further requests on the partner portal. So for us, we have to request the enable cascade delete feature. Then once we have our org, we need to the org doesn't contain anything, so we need to push our code into the org. Then we have other security settings to enable, so we need to make the org available from within our office. So we have to add in the IP addresses. We have 10 or more developers, so when you create the org, you only get one user, so we have to create those users. And then there's other settings that you might need to enable. So for example, you might want to turn on product scheduling or some other options. But all of these tasks take a long time, so whenever you need a new dev org, it's a big delay before it's ready to go. So how did we overcome this? Well, we created a collection of reusable orgs. So we just spent a day creating a whole pile of orgs and going through this process for a whole load of them. So we actually have 30 orgs that we use for development in the TAS group. And they're just a collection of them that we reuse as and when we need them. And one thing to note about this that we found quite useful is we made sure that we have orgs in different regions so that when Salesforce are doing their upgrades, we have the ability to develop in the current version and the coming version. And we also have one org that we use now and again that's on the pre-release version. You can get dev orgs that are for the upcoming version. So we keep one of those just for advanced testing of our code. Okay, so as I mentioned, we have 30 orgs, but that's a lot of orgs to maintain. As in, how do you know which org you're going to, who's using what? You don't want to get lost in the cloud of orgs. So how do we solve this? Well, quite simply, we use a list. We maintain a list of the orgs, and we use a reservation system. So at the moment, we're using a wiki page, and it's just got a table that has a list of the orgs. It just has a bit of information about the org, so it tells us what's the namespace for the org, what's the ID of the org, what region is it in, is it a multi-currency org or not, these kind of things. And then we have our reservation information. So if these fields aren't blank, then it means it's in use by someone. So we put in the project name, we have there a link to the actual source code, so what code is in there, and also who's using this org. So just in case there's any queries as to why a certain org is being used, we can always trace who's actually using it at any one time. And you might notice that this image is actually not our wiki page that I talked about. This is the environment hub, because we're actually switching over to using the environment hub for this. It's a perfect fit for what we're trying to do. So all this is the regular environment hub interface, but we've just added a couple of custom fields on here so that we can put in our reservation information. And eventually I'm hoping to automate this process, so rather than having to go to a wiki page and manually doing it, that when you just go to deploy your code, it'll go and reserve the org for you. Okay, so now we have our org, so you get your org from the list and you mark it as reserved, and now you need to do something with it, but there's no content in it. So how do we get our code into it? So we need all our Apex and our Visual Force and all this kind of stuff. We need to get all of our code base in there. And how we do this is using the migration tools. So it's the Salesforce Migration Tools and Apache Ant. And the three primary functions we use on this are the deploy, which pushes your code into the org, the retrieve, which will get you code out of an org, and what we call an undeploy. So an undeploy is just deleting content from an org, so you can clean it up and make it usable again. And I just want to give a bit of a call out here to Financial Force and Andrew Fawcett, because they provided us with some development tools they had for doing this kind of work. And we found them really, really useful when we were trying to build our tools. They were very, very helpful. So big thanks to Financial Force. So a little bit more about this deploy, retrieve, and undeploy. So while Salesforce gives you the Ant targets, or these tasks that you can use to do these, we have a little bit extra to do for each of these steps for these to work for us. So if we want to put code into the org, it's not just a case of pushing code in. We have to prepare the code a bit as well. So we have a couple of manual steps that we do for our tasks. If you look here, we've got to reserve the list in the org. So like I showed you earlier, the list of orgs we have, we need to make sure that we've reserved an org that's free. And if we're undeploying, when we've deleted all the code, we need to make that org available again. So we need to clear that record in the list so that other people can use it. Then we have some Ant tasks. So these aren't the migration tool tasks. They're not the Salesforce tasks. These are just file manipulation tasks that we do before we actually go on to the actual deploy or retrieve and so on. So I'm not sure if you remember, but on the list of development orgs that I showed, each of them has its own namespace. We use a namespace to identify the development orgs. So like we have dev 1, dev 2, dev 3, all that kind of thing. But our code always contains a generic namespace. So when we're going to deploy code into a dev org, we need to substitute in the namespace. So we just use an Ant replace task to do that. Similarly, when we retrieve the code out of an org, so when we download all the Apex and Visual Force and so on, that's going to have references to all the namespaces for that dev org. So we need to revert that back to the generic namespace. And then the undeploy is a little bit more complicated. So I'm not sure if any of you have tried to undeploy code from Salesforce before. Yeah. And it's hard because of dependencies. So even if you give what's called a destructive changes XML to Salesforce and tell it to remove everything, it won't. Well, we found when the package gets big, it can't do it. It just gets lost in dependencies. So how do we get around that? Well, break all the dependencies. So we use Ant to blank all the code. So the classes now contain no code. They're just empty files, the triggers, formulas, all of that. Everything, it just becomes empty. So when that's pushed into Salesforce, then there are no dependencies between all those objects. And then we have the actual Salesforce Migration Tools part. So for the deploy, we actually push the code, so our zip file containing all our metadata into the org. On the retrieve, well, it's pulling out a zip file containing all the content. And for the undeploy, it does a little bit more there. Again, the undeploy is the more complicated part that we spent a good bit of time on. So to start with, we deploy all that blanked code, so the stuff that we used, or all the content that we used Ant to replace with empty files. We deploy that, so all the dependencies are gone. Then we have to undeploy hierarchical rollups in sequence. Again, it's something that the Salesforce destructive changes can't handle. If you have a hierarchy of rollups and you try to remove them all at one go, it doesn't work. So you have to do them in sequence, one by one by one. We've just automated that in Ant. And then finally, once you've done that, you push the destructive changes with all the content, and the org is now empty, ready for reuse. Okay, so that's how we handle the organization restrictions. Next, we'll look at version control. So why use version control at all? Well, for us, the biggest thing is the branching and merging. I'll be discussing branching and merging shortly, but really what that gives us is our ability to isolate features. And again, I'll be talking about that a bit more, but this just gives us the ability to do that, and you'll see why it's important in a little while. It also gives us a code history or an audit trail, so we always know what changes were made, who made the change, and when it was made, so we can track bugs and so on. It's also helpful for collaborative development, so having code in version control means we can share the code very easily. And it also prevents losing code. As I mentioned earlier, what happens if somebody accidentally corrupts an org or puts a whole load of incorrect Apex into an org? Have you lost your code? Well, no, not if it's in version control, because you have an offline copy of it that you can put back as needed. And the choice of version control tool, there's lots out there. So, I mean, I guess some of the more popular ones are Mercurial and Git and Subversion, and I guess it's kind of obvious which one is the market leader at the moment. I mean, everyone's raving about Git, and sure, of course you'd use that. But no, we don't. We use Subversion, and we use it for a couple of reasons. I know a lot of you are probably tutting out there going, oh no, it's Subversion. But actually for us, it works fine. It's a legacy thing in that we have a lot of knowledge in Subversion, but also it does everything that Git does, but the advantage of Git is that it's a distributed version control tool, which is great if you're working with lots of people who are distributed around the world and so on, and you're pushing and pulling code. But for us, we're actually kind of going the other way if you think about it. We're taking code out of a number of orgs that are in the cloud and putting it into version control. So it's kind of from distributed into a centralized, so that works well for us. But all the stuff I'm talking about today can be done with any version control tool you want. It's just a case of some extra Ant tasks. Okay, so a little bit about branching and merging. So code in a version control system is just a collection of files and folders, or files and directories with some metadata, and the metadata is just used by the system to identify changes and to track what happens. When you create a branch, it's just creating a clone of those files and directories. And again, it creates some extra metadata so it can track the source of where it came from, and it'll be able to manage changes that are done on the branch or on the source repository in isolation. And again, because we're using Subversion or SVN, we always refer to our main source or our origin repository as trunk. So merging is when you bring the work that you've done on a branch, or you have changes on a branch, back into its source. So in this case, we're bringing the project branch back to trunk. However, merging isn't only just one way. If we've been doing work on trunk while the other project was in progress, they can be merged up as well. So you can keep the two of them in sync. One thing to be aware of is you can end up with conflicts in merging. Like I was talking about earlier with the orgs, if two people make changes to the same file on the two branches and you try to merge them, the version control tool can't automatically figure out what to do there. Someone has to decide what's the right code to put in when a conflict arises. Okay, so how do we do this automated version control then? Well, we have a simple scenario here where we have one of the dev orgs that was reserved by a developer, and then they use whatever tool they want. So they've pushed in the code with Ant, and now they're going to use, in this case, Maven's Mate, and they work away happily making all their changes. Great. But how do we make sure those changes don't get lost? Well, we use a Jenkins server, and a Jenkins server it's what's called a continuous integration server, but for the purposes of this, just think about it as a server that can periodically or on a schedule run a job. So in this case, it's actually going to pull the code from the dev org. So it's going to do our Ant retrieve task that I talked about, or using the migration tools, it'll get the code. And it commits those files and folders into SVN. So the developer actually doesn't have to do anything. The developer is working away happily, just focusing on their Salesforce development, and in the background, all their code is automatically going into version control. But it gets a bit more complicated than that too, because we have up to 30 dev orgs, as I mentioned, and Jenkins knows which org corresponds to which branch in SVN. So it just periodically keeps pulling all the content out of the dev org, and it puts it into the corresponding branch in SVN. And in that way, we don't lose our changes. And one important thing to notice here is it doesn't matter for us which client a developer uses for working in Salesforce. So they can use Eclipse if they want, they can use Maven's Mate, they can work in the browser. It doesn't matter. All it has to do is get into the org. If they save something and it compiles and gets to the org, we can put it into SVN, it's fine. So it takes the onus away from the developer of having to make sure that they've checked in their code before they go home from work and so on. Okay. So that's how we handle the version control. Next, we'll look at how we handle the automated testing. So as I mentioned earlier, we need to do automated testing to ensure that when we make changes to code or when we add new code, that we don't break the code that was already there, and that we have some way of validating the new code is doing what it was intended to do. So we do this through Apex test code. How we automate this is we have a special org that's reserved for testing. And that special org is just like a dev org, except we restrict access to it. We don't allow anyone to push code to it. It's only the automated process is allowed to do that. And we never actually persist code in there. How do we do that? Well, we use the migration tools, but we use a feature of the migration tools that's a test deploy. So earlier on, I was talking about how we push our code into the org using the deploy. Well, the test deploy does the same thing. It packages up all the code, tries to push it into the org, checks everything compiles and everything's okay. But after that, it doesn't persist the code in the org. The org is still empty. It's just a test to see will it deploy. And then there's another flag you can put with that. That's the run all tests. So when it gets to the point that it's validated, the package can go in and will compile. It'll then run all the tests that are in the Apex. And when all the tests are finished, either with a fail or a success, the org is still empty. And again, we use Jenkins to handle this. So currently, we schedule our jobs daily. But we also have them run ad hoc as we need them. So during the day, sometimes we'll find we need to test something quickly, or some code has changed and we're concerned that it might affect something. So we can just go to the Jenkins interface and click a button, and it runs all the tests for us. And we get notifications of any failures. And when we get the notifications, it gives us the logs. So a little bit more on how this works. So similar to before, we use the retrieve task from Jenkins to take out all the code, so your Apex, your Visual Force, all your metadata files, basically. It then does the test deploy with the run all flag. We get a response back from the org saying all the tests passed in this case, and then if that's the case, they all passed, Jenkins just marks the job as green, it's done, we carry on. If there's a failure, then Jenkins will email the development team with the log so we know what failed. And we look at all the emails every morning to see what has failed or what's changed, and we allocate out any failures among the developers to be fixed before we carry on with any further development. We don't want bugs to be persisting too long. The longer you leave a bug, the harder it is to fix, or even the harder it is to remember what changed that might have caused that bug. So we try to keep on top of our bugs or test failures as early as possible. So that's how we do the automated testing. Next, we'll look at the isolated feature development. And I think this is the one that's probably helped the development team the most. This is the one that's kind of given us the speed of development that we wanted. So what do I mean by isolated feature development? So we want to keep all our new features or our projects separate. We don't want to be having multiple features in one dev org. So we have a ratio of one feature to one development org. And we have one SVN branch that corresponds to that dev org. And we deploy that branch code into the dev org. So by doing this, we can avoid having any problems in our packaging org, because we're doing them in dev orgs that are separate. And it's only when we're finished a feature, or when we're ready to bring it back into the managed package, that we do the merge. So basically, our managed package remains safe and secure. We're not damaging it while we're developing new features. The other great thing about this is it prevents accidental dependencies. If we just have one dev org and we're trying to build, let's say, 5 different features, so we have feature A, B, C, D, and E, and then all of a sudden our management comes and says, actually, no, we don't want C. We have to get rid of that. It's a really hard job to try and unpick that code so that you still get the other 4 the other 4 features and not C. This way, if they come along and say we don't want C, you just don't bother with that branch. You leave it alone, and you can merge the other ones. And the other thing is, because all the features are kept separate, you have fewer developers and less code churn going on, so you end up with fewer conflicts. So how do we do the branching in Force.com? Well, as I mentioned earlier, the trunk is the main sort of source branch in SVN. So that corresponds to our publishing org. So whenever we're going to create a branch, we just make sure that our trunk has been updated from the publishing org, so we have all the latest changes from that org. Then we create a branch in SVN. This branch now contains all those changes. We push that branched code into one of our reserved dev orgs. And as the developers are working away, Jenkins is in the background taking out all the changes and putting them onto the branch. And when the feature is ready, we merge that back to trunk. Now at this stage, the changes are only in SVN. We have to now put them into the packaging org. So we deploy them to the packaging org. And at this stage, the dev org that we were working with is finished with. So we can undeploy it, make it available again, and reuse it for later features. Okay, so that's the isolated feature development. Next, we'll look at continuous integration. So as I mentioned, the continuous integration is that we don't want our different branches to be sitting out on their own or to be being worked on without being synced with our other branches. Because if you do that, you can end up with really difficult merges, or you can end up with features that are incompatible. And that's a bad situation to be in. So you want to make sure that all the changes that are going on are synced across your branches frequently. And in our case, we have a number of different orgs that we use for our Salesforce apps. We have our packaging org, which I mentioned, so where we build our managed packages. We have patch orgs, so where we make fixes to previous versions of our managed packages. And we have all those feature orgs I was talking about. There's the dev orgs, those 30 orgs that we use. So if we find a bug in an old version, so if we have a patch org and we find a bug, we need to propagate that bug forwards. There's no point in just fixing that in the patch org, because then the future patch orgs won't have it, your trunk or your packaging org won't have it, and your dev orgs won't have it. So you could lose that fix. So you need to make sure that you get that bug migrated from the earliest version all the way forward. And we can do a lot of this automatically. We have Jenkins do the merging for us. But it can only do it in a couple of scenarios. So if there's no conflicts, it can do it fine. If there's a conflict, Jenkins can't decide what's the correct code to put in. So it'll flag to us that I can't merge, you need to look at this and merge that manually. And we only do it if the tests pass, because we don't want code that's changed that's actually causing our tests to fail to start shipping around. We only want clean code to be merged automatically. And if we meet those two restrictions, that there's no conflicts and that all the tests pass, Jenkins will automatically merge the code and push it into the org. So how do we do this? Well, we just created a couple of Ant tasks for SVN merge, and this is how I'm saying you can use whatever version control tool you want. You could just write some tasks for Git or, basically any subversion, or sorry, any version control tool you wanted. And we use Jenkins to automatically control the order. Jenkins knows the sequence of patch orgs to trunk and to the feature orgs, or the dev orgs. So Jenkins will start at the earliest patch org and then merge forward. So if we had our earliest patch org is 1.1, it'll merge from 1.1 to 1.2 to 1.3 and so on. When it gets to the highest version of the patch orgs, it'll then merge to trunk. And then from trunk, it'll merge to all the feature orgs. Now, just one thing to point out there is when we're merging from trunk, it's not a hierarchical thing like the patch orgs there. It's trunk to each dev org or feature org. So it's trunk to dev org 1, trunk to dev org 2, and so on. The only manual merges that we need to do, or the ones that we just don't ever let Jenkins do, are merges from trunk to patch orgs, and I'll talk about that in my next slide, and merges from feature orgs to trunk. And the second one I think is probably a bit obvious from what we were talking about earlier. When you're developing features, the code could be unstable. You don't want that going into your trunk, which is your packaging org, because you want that to remain stable. So only when you're happy with the code in your dev org do you bring that back down into your packaging org. So let's look at a bit of an example of how this works for us. So we have our trunk, which corresponds to the packaging org, and we have a patch 1.1 branch that corresponds to our 1.1 patch org. And we decide, right, we need a new feature, so we create a branch A, and that gets synced with a dev org. But while we're working in that, someone fixes a bug in 1.1. So Jenkins automatically merges that up to trunk, goes into the packaging org, automatically merges it up to the patch branch, or sorry, the feature branch, and that gets pushed to the dev org. And when we're ready, we merge that down to trunk. That's the manual merge there. And we push that into our packaging org. Then we decide we're going to build a package now. So our new package, our managed package, has the feature A in it. And we create the managed package. We then create the patch org for that managed package. And we create a new branch in SVN. So we create 1.2 from 1.1. And that is synced with our new patch org. And we do a merge down here. So this is the one I was saying I need to explain a little bit as to why we merge from trunk down to the patchwork. And this is just so SPN understands the history of the files. It can understand the ancestry of where all these files came from. And by doing this, we found that SPN works perfectly for us. It'll always be able to trace files all the way through. So then let's say we want 2 more features. So we do the same thing again. We create branches, we sync them with orgs, and we have some bug fixes going on. So Jenkins merges them across and deploys them to the orgs. And then we decide our features are ready. So we bring them down into trunk, and we're going to build a package. But, oh, hang on, somebody noticed there's a bug in 1.1, so that gets merged forward to 1.2. And then there's another one, and then we bring it back to trunk. So we don't lose any of the changes. They're all going to be in the package. And then we create the package. We've now got or managed package. We've now got 1.3, and we create another branch for 1.3 and so on. And just the cycle continues. It's just this over and over and over again. And in fact, while this diagram probably looks complicated, we've done this with dozens of feature orgs and dozens of patch orgs. And it's actually quite simple because you only look at one org and one branch at a time. And SPN does all the hard work for us. Okay, so that's continuous integration. So it improved things for us because a lot of it's automatic. We've 10 developers, it all works well. We have a quarterly release schedule. Basically, things have just got better for us. It's helped our QA team because they can see our code earlier and so on. It's just had a lot of benefits for us. And some good news is we've decided we're going to make all our tools available. Still deciding on exactly how and when, but if you follow me on Twitter, I'll announce the details of that as soon as they're ready. But we're going to have these tools available for everyone. I've just added a few useful links here. These are just some of the tools that were involved. And that's it. So anyone have any questions? Oh, yeah. So I think there's a microphone over there if you want to go to that. Okay, the links, yeah. I'll post up these slides on the chatter for this session as well, so you'll be able to get them.
How exactly did you figure out how to unmap the rollup fields?
Well, basically we're using regular expressions. So we pull down all the files and we just have a few regular expressions running through that. So we identify where a rollup references another rollup, and then we just build a map of which ones reference which. We start at the top of that map and undeploy that one, undeploy that one, undeploy that one, and then they're gone.
Awesome.
I have a couple questions.
Sure.
First, how come you just use a persistent sandbox that you blow out and redeploy to rather than doing a sandbox refresh?
Sorry?
How come you don't use sandbox refreshes? Rather, you kind of just delete all the code in one of your developer orgs and redeploy all your code?
Well, for us, the sandboxes are good, but if you think about it, there is a cost involved with them. There is a delay in preparing sandboxes, so if you want to refresh a sandbox, it can be, I don't know, minutes to hours to get them. With this, we can do it whenever we need. So if we always have a set of orgs ready to go, so whenever our boss says, right, we want a new feature, we start within minutes. We don't have to say, okay, we need to do a refresh. We can do it whenever we need to. And also because we have all our orgs undeployed, all the settings remain. So the things like the cascade delete and so on that I was talking about are all always available for us. Our dev orgs are always configured the way we need them. And it also has the advantage, as I mentioned, that we always have the orgs we need even during the Salesforce upgrade week. You know, the way they do some one week and some the next week. We always have orgs that are either side of that. And then outside of the upgrade week, we always have a pre-release dev org available as well. So.
Okay, thanks. And second question is, which branch do you do the automated testing? You mentioned you had a scheduled test that runs every day or so.
Oh, all the branches.
So every single branch has...
Yeah.
Okay.
Yeah.
Thank you.
That's just because we want to make sure that all the patch branches have valid code, our packaging org is valid, and that all our dev orgs are valid. Obviously, the dev orgs, you know, they become a bit unstable and back and forward, but it's just keeping the developers aware of what changes are there. So.
Thank you.
Okay. Okay. Well, I'll do one more question quickly. I think we've just run out of time. So I'm going to go down to the end of the room for any questions after this one, and I'll answer them there. So if you want to go ahead.
Yeah, just a question. With my experience with CI servers, they're usually polling the SVN repository for changes. Mm-hmm. You had it polling Salesforce for changes. I'm wondering how that sort of worked.
No, well, we could have done that. I mean, you can look at the audit information from Salesforce to see when changes have come in. But what we've actually used is a 2-hour schedule because we found that works fine. And what we bring down as part of the extract from the org is an audit log that tells us the name of the last person to modify the file and when it was changed. So although the code is being pulled down as one user, we know who made all the changes to the last files. And although it's only as granular as the 2 hours, we haven't had a problem with that. It's worked quite well for us. And if we needed, we could change it to 5 minutes, 10 minutes, or as you say, we could poll on the audit changes. So, okay, so if there's any more questions, I'll stay outside the door for a little while, and if anyone wants to come up and ask me questions, please do. Thanks.